Hello everyone, welcome to physics online classes for class 11 students. Let us continue chapter 4 motion in a plane. Today we are going to study about types of vectors. In the previous class we studied what are scalars and vectors with some examples. You can remember what are scalars and vectors. Yes, scalar, it is again a type of a physical quantity because we know that physical quantity is divided into two types and they are fundamental quantity and derived quantity. About these two terms we have studied in the chapter units and measurement. But here the same physical quantity again it is divided into two types and they are scalars and vectors. So here scalar is a physical quantity which is having only magnitude but there is no particular direction. So we are going to call it as scalar quantity. For example, distance, speed, time, mass. So these are what scalar quantity. These are having only number, numerical value, magnitude, but there is no direction. The second one is vector quantity. Here vector quantity is having both magnitude and direction. For example, we can take a force. Force is a vector quantity because we are going to express force in terms of numerical value. For example, we can take 5 Newton. I am going to apply force on the object towards north direction or towards east direction. It is having particular direction as well as magnitude. So we are going to call it as vector quantity. So we studied about scalars and vectors in the previous class, but today we are going to study about how to represent vectors and what are the different types of vectors. So now let us start the types of vectors. Yes, before going to study about the types of vectors, first we have to know how to represent vectors. We can study representation of vectors. Now let us consider example displacement. Displacement is a vector quantity because it is having both magnitude and direction. So now displacement of a body from A to B is represented as, we can consider displacement of a body from A to B. You can observe this picture diagram, A to B. That gives displacement and we know that displacement is denoted by the letter S. We have to write arrow mark on the letter S that represents vector quantity because displacement is a vector quantity. Symbolically, how to write this vector quantity? You can observe AB arrow mark, AB arrow mark is equal to S arrow mark. So here distance or the displacement of a body from A to B with arrow mark which is equal to what? Displacement, and it is denoted by the symbol. Yes, we have to write arrow mark on the letter that indicates vector quantity. Magnitude of AB is equal to, we have to write mod AB. Remember, whenever you are going to write only its numerical value, only its magnitude, then we have to use mod. Mod of AB that indicates magnitude, or we can write simply AB. So that gives magnitude of that value, that is displacement, right? Vector quantity is represented by a straight line with an arrowhead, arrow mark, directed line segment. You can observe this diagram O to P. So we are going to draw a straight line with arrow mark or arrowhead. The length of a line is equal to, or it is proportional to, magnitude. So length between O to P, that length gives magnitude and that arrowhead shows direction. Because vector quantity is having both magnitude and direction. O to P, the length of O to P gives magnitude and this arrow mark indicates direction. Here vector A, how to read here? This is vector A. On the top of the letter A we have to write arrow mark. This is what? Vector A. A is a vector and it is represented by OP arrow mark. Right? Where OP, mod OP is what? Magnitude of the vector OP. This gives only magnitude. Or when I am going to write mod A, that gives magnitude of the vector A. What is O here? O indicates a tail or origin of the vector. It starts from the initial position O. So we are going to call it as origin or tail of the vector, and P indicates head or terminus or tip of the vector. Is it clear? Yes, how to represent vector? Vector is represented by a straight line with an arrow mark, right? So the length of the line is magnitude, that indicates or that gives magnitude, and that arrow mark or the arrowhead gives direction. So this is all about the representation of vector. Now we can study about types of vectors. There are many different types of vectors. So we are going to study some important types of vectors which is for your syllabus. The first one, polar or true vector. What is the first type of the vector? Polar or true vector, right? Then what is polar vector or what is a true vector? You can read this definition. A vector whose direction is along the direction of motion of a particle. That gives polar vector or true vector. For example, the object, let us consider this is object A. This object is moving along this direction. It is moving, let us consider this is from east to west, right? So along this direction, the vector whose direction is along the direction of motion of a particle, then we are going to call it as a polar vector. Right? So why we have to call it as a true vector? Because it is really moving along the direction of motion of a particle. Yes, what is polar vector? A vector whose direction is along the direction of motion of a particle. That gives a polar vector, or it is also called as a true vector. For example, displacement. Yes, what is displacement? The shortest distance between any 2 points. Let us consider A to B. The shortest distance between any 2 points is called displacement. Displacement is a true vector or a polar vector because its direction is along the direction of motion of the object. Similarly, velocity, because velocity is a rate of change of displacement. Similarly, acceleration is, what is acceleration? Acceleration is rate of change of velocity. So that's why these are the some example for true vector or polar vector. You can take linear momentum. Linear momentum is denoted by P, which is equal to m into v, mass into velocity. Velocity is a true vector, polar vector. That's why linear momentum is also polar vector. Then force. Force is given by the equation F equal to ma. A is acceleration. Acceleration is what? Polar vector. So these are the some example for polar or true vector. Is it clear? Yes, what is polar vector? A vector whose direction is along the direction of motion of a particle. Then we can study the second point, second type of the vector, axial or pseudo vector. It is exactly opposite to first one. The first type of the vector is true vector or polar vector. And now this is axial or pseudo. Pseudo means false, which is not true, right? Yes, how to define axial or pseudo vector? A vector whose direction is along the axis of rotation of a particle. That gives axial vector. For example, if the object is moving in a circular path, which type of force is required for circular motion? Already you have studied in your high school days, you can remember centripetal force and centrifugal force. So what type of force is required? Centripetal force is required, and that force is always acting along the radius towards the center. So that is centripetal force. Because of this centripetal force, object is moving in a circular path. Yes, how to define axial vector? A vector whose direction is along the axis of rotation of a particle. For example, angular displacement. Angular displacement is denoted by the symbol theta. Yes, here angular displacement, for example, the particle, it is moving from A to B, right? That gives certain angle which is denoted by theta. Theta is angular displacement. The angle described by the particle about the axis of rotation, that gives angular displacement, and this is a axial vector because it is along the axis. Why we are going to call it as a false vector or pseudo vector? Because it is just imaginary. You can remember, whenever you are moving in a circular path, always the body of a particle, for example, when you are sitting in a bus, passenger, he is falling away from the center, that is called centrifugal force, which is pseudo force. So that's why axial vector is also called as pseudo vector. Similarly, angular velocity. Angular velocity is denoted by omega. Omega equal to theta divided by t. That is rate of change of angular displacement. Then angular acceleration is denoted by alpha. Alpha equal to omega divided by t. Omega means what? Angular velocity. Angular velocity with respect to time, that gives angular acceleration. Similarly, angular momentum, which is given by the equation L equal to I omega. Then torque tau equal to R cross F. So these all terms are related to rotational motion. In the first type of vector, we studied displacement, velocity, acceleration, linear momentum, force. Those are related to linear motion, and these examples are related to rotational motion. Here we have to consider the vector along the axis of rotation, right? And you can remember one important note here. What is that note? A physical quantity which is neither scalar nor vector is called tensor. Neither scalar nor vector. A tensor has no particular direction. It can have different values in different direction. That means some quantities, magnitude and directions are changing according to their direction. For example, moment of inertia and stress. About moment of inertia, you are going to study in the chapter system of particles, which is given by the equation I equal to mr square, right? And about the stress, you are going to study in the chapter mechanical properties of solid, right? Stress is restoring force per unit area. These are not having particular magnitude, particular direction, neither scalar nor vector. So we are going to call it as tensor quantity, or simply we can call it as a tensor. Scalar, vector, tensor. Scalar is having magnitude. Vector is having both magnitude and direction. But tensor, neither scalar nor vector. So this is the second type of vector. Come to the third point or third type of vector, that is collinear vector. Collinear. Co means what here? Same. Linear, straight line. Collinear vector. How to define collinear vector? Two vectors having equal or unequal magnitudes and acting in the same direction or in the opposite direction. These are called collinear vectors. Yes, what are collinear vector? We should consider two vectors. These two vectors may be having equal magnitude or unequal magnitude. That may be moving in the same direction or that may be moving in a opposite direction. So these are called collinear vector. You can observe these pictures. In the first example, in the first picture, the two vectors are traveling in the same direction. But in the second picture, vector A and vector B, these two are traveling in the opposite direction. And in the third example, Vector A and vector B, they are following each other. So that may be having equal or unequal magnitude, same or opposite direction. So these are called collinear vectors. Then next one, parallel vectors. Yes, parallel, two vectors acting in the same direction. Then we are going to call it as parallel vectors. Yes, how to define parallel vectors? Two vectors acting in the same direction. The direction should be same. These two vectors should be parallel to each other. So we are going to call it as a parallel vector. Note, angle between two parallel vector is how much? 0. Because you can observe these two vectors are parallel to each other. So angle between these two parallel vector is how much? 0. You may get 1 mark question or in multiple choice question in any competitive examination like what is the angle between two parallel vectors? The answer is what? 0. Because these two vectors are traveling in the same direction. Then next one, anti-parallel vectors. Anti-parallel vector is exactly opposite to parallel vector. Yes, how to define anti-parallel vector? Two vectors acting in the opposite direction, then we are going to call it as anti-parallel vectors. Vector A is moving in the forward direction, vector B is moving in the backward direction. Exactly both are opposite to each other, so we can call it as anti-parallel vectors. And angle between two anti-parallel vector is how much? 180 degree. You can observe this is vector A. Right, it is moving in this direction. The vector B is moving opposite to that. So angle between them is how much? 180 degree. Angle between two anti-parallel vector is 180 degree. The next one, concurrent or co-initial vectors. Concurrent or co-initial. That means the vector having same initial point are called co-initial vectors. If all the vectors are starting from the same initial point, you can observe this picture, it will be very clear. From the point O, all these four vectors are moving from O to A, O to B, O to C, O to D. The vectors having same original point or initial point, then we can call it as co-initial. Co means what here? Same initial point or same initial vectors. The next one, localized vector or bounded vector or fixed vector. A vector whose initial point is fixed or tail. The initial point, if it is fixed at a certain position, then we can call it as localized vector. If that vector is starting from the point A, it is moving like this. So this point or this initial point or this tail should be fixed at a certain position. Then we can call it as a localized vector or bounded vector or fixed vector. Then non-localized vector or free vector. It is completely free. A vector whose initial point or the tail is not fixed. If its tail is not fixed, if it is not having a particular initial point, then we can call it as non-localized vector. Localized vector is having fixed tail. Non-localized vector is not having fixed tail. The next one, coterminous vector. Terminus. That means the head of the vector. Coterminus. The vectors having same terminus point or the same terminus head, they are called coterminous vectors. Vector A, vector B, vector C and vector D. All the four vectors are going to meet at a single point. At point P they are going to meet. So we are going to call it as coterminous vector. Then next one, coplanar vectors. Coplanar, same plane. Plane means two-dimensional, right? The vectors lying in the same plane are called coplanar vectors. Now you can observe xy plane, xy axis. all the vectors are lying in the same xy axis. So we are going to call it as coplanar, same plane. Right? Then next one, displacement vector. Yes, a directed line segment from initial to final position of a particle in a given time interval is called displacement vector. A directed line segment, I can draw this, this is a line segment from initial to final position. Let us take from A to B in a given time interval. So we are going to call it as displacement vector. Yes, what is displacement vector? A directed line segment from initial to the final position of a particle in the given time interval is called displacement vector. Then resultant vector. The resultant of two or more vectors is that single vector which produces the same effect as individual vector together would produce. That means there are two vectors, vector A and this is vector B. So the resultant of these two vectors is equal to a single vector. Let us consider P. The resultant of two or more vector is that a single vector. This vector produces the same effect as these individual vector together would produce. Right? When we combine these two vectors, the resultant is represented by a single vector. So we are going to call it as resultant vector. For example, I am going to consider this is vector P, this is vector Q. The resultant of these two vector, I can directly draw the diagonal. Here this is the vector R. This is resultant vector. Is it clear? So these are the different types of vector quantity. So these are the different types of vector quantity. And in the next session, we can study some special types of vector quantity.